Hello everyone, welcome to this channel. Today we are going to begin our system design knowledge, the very first session, which is to introduce the high-level components of a system and the high-level architecture and the different kinds of architectures of a system. Okay, so before we talk about the system design, we should understand what is a system. Okay, so in this session and in all the following up sessions, we will talk about a web-based session and a web-based system. So basically it means either a website or either a mobile phone app. Okay, so this is the system we are talking about. And also we will have several sessions where we will talk about some details of a system, where we can also call a subcomponent of the system also as a system, right? So for example, in the infrastructure level, how you design a database system, even though it's very, very behind the scene of a web-based app or a mobile app, it's still a kind of a system, right? But it's just an infra system. We will also talk about those kind of systems later, maybe 5 or 6 sessions later. But in this session, we are going to talk about the basic components of a system. Okay, and here let's begin. Okay, so let's talk about the components first. So from the very high level, when you use an app or when you use a website, definitely it needs to have a component which is app itself, right? So let's draw it here. Okay, so first you need to have the app, which can either be a website app or it could be a mobile app, right? Where the user can interact with, where the user can send a request, right? Okay, now you have the app, but can app alone work? Yes, in many cases. For example, in App Store, when you download a calculator app or when you download a calendar app, in many cases, yes, you don't need any other resources. You just need the app itself alone on your mobile phone because it can just leverage the resources of your phone or your device, right? However, there are many other apps where it needs resources from other places, so which is outside of your phone, right? In those cases, the app needs to request those resources, or they can create new resources and put them in the other place, right? And for example, let's say you are using a TikTok app. How can you get those videos? How can you get those recommended videos, right? Or how can you get the people you are following? Those resources or those data are not on your phone or on your website or in your browser, right? They are in the TikTok's servers. So, and also for Facebook, for WhatsApp, and those other apps, they all need their own servers, right? So the app will talk with our second component of the system, which is the server. So the server is hosted and owned by the business themselves. So for example, TikTok have their own servers, Facebook have their own servers, right? And okay, so the app will send request to server to request the data or to create new data, right? Okay, now we talked about, app will talk with the server to send data and request the data. So where the data is actually stored, right? So let's talk about it. Usually we use database, no matter what kind of database, right? So either it's a MySQL database or it can be a MongoDB, which is document database, right? So no matter which kind of database it is, it's database. So our data will live in our third component, which is database. So basically the app cannot directly interact with the database. It's usually through the server. So the server will talk to database to retrieve data or to store new data into itself, right? Okay, so from the high level, these are the three components we have, okay? Components of a system. Okay, so in future, when you have a system design question or you think about how a system works, usually it's just these three components. Yeah, I know for many apps it's more complex than this, but from the very high level, when you talk about a system to others, it's just an app, server, and database. So this is from the high level, okay? In later sessions, we will talk about more about the server itself and the databases, because there could be some subcomponents for the server and subcomponents for the database. Okay, cool. We talk about the components of a system. Okay, so we talked about the different components of system. So what about architectures? I believe you have heard a lot of things about architectures of system, but also from the high level, let's see, okay, architectures of system. So most commonly, you will hear about two types of architectures of a system. And when you design or when you even start up your own app, you usually need to choose between one of these two architectures. The very first architecture is called Monolithic Architecture. Okay. So what is monolithic architecture? So let's still consider an app, okay? So here you have an app. Let's say it's a TikTok app, okay? And in monolithic architecture, everything behind the app is in a single code base, and also they are deployed together. So let's say the TikTok app, let's say they have different features, okay? So let's say they have the video recommendation feed, okay? So this is the first screen you see on your TikTok, where they show a non-stoppable, scrollable feed of videos which they recommended to you, okay? They could also have e-commerce feature, okay? Where you can buy and sell products on their platform. Or you could also have maybe chat feature, okay? Where you can chat with your friends. And also you have, let's say, people following feature, where you can follow other people or you can see who followed you, right? So you could have all these kind of different features. So in a monolithic architecture, all these features, they will be in the same code base. And they will deploy it onto the same machines all together. Okay, so here, so they are all in single code base and single deployment. Okay, so what does this mean? This means all your codes will be a same code base, and they will be compiled together. And after you have the binary file, and then they will be deployed onto machines all together. So they always live together. Now let's see what's the pros and cons of this kind of architecture, okay? So why would you want this single code base, even though you have so many different features, okay? And why you want to deploy them on the single deployment? Okay, so let's write this down. Okay, pros. Okay, the first thing is it's very simple, right? So it's basically like you start writing your code for an algorithm or any simple features. You just use a single language. For example, you use Golang or something to write those codes, right? And maybe you have a video recommendation feed where you implement it as a video recommendation class, or you have an e-commerce feature where you implement it as an e-commerce class, right? And so you have different folders, or so one folder for video recommendation, one folder for e-commerce, one folder for chat, right? So that's very easy, right? So it's in the same code base. It's very easy for you to write codes. Okay, so it's very simple to start if you are a startup company or you just write a simple app, right? However, and also secondly is that it's easy to debug because it's all the codes are together. So especially when different components or different features talk with each other, because they are all in the same code base, all the logins are together, right? So it's very easy for you to trace down where the problem is. So this is why you want to use a monolithic architecture. However, this kind of architecture have a lot of cons, a lot of problems. Okay, so the very first problem is you have to use a single technology or language, okay? Because they are in the same code base. So in most cases, it means you have to write all the features together with the same language. For example, Golang or Java or C++, right? So, but when your team grows bigger or when your org grows bigger, maybe one team will be in charge of video recommendation feed and they are more familiar, or for this feature it's more feasible or it's more flexible to use Golang, right? However, for the e-commerce feature and that team in charge of the e-commerce feature, they choose to use Java, right? So you cannot mix Golang and Java together in the same code base, right? So this brings this kind of problem where different teams must use the same technology or language, right? The second one is the single point of failure, okay? Because they are all in the same code base, which means they will be compiled to the same binary file which you must deploy to all the machines, right? So all the features are in the same code, same binary. So let's say the chat feature has some bugs and it throws exception and error, and you don't have a good mechanism to capture and handle these errors yet. Then this kind of error from the chat component will just crash the whole process, which means it will crash all the other features, right? So the whole system will be down just because this chat feature has some bug or the chat feature is down, right? So this is single point of failure. The third one is the scalability, okay? So in this, let's still take TikTok as an example, right? So in all the 4 features we listed here, you can imagine video recommendation feed feature is definitely the one everyone uses every day, right? Because it's the first screen you see when you go into TikTok app, where it recommends non-stoppable videos to you, right? So this is a feature everyone uses. However, for e-commerce feature, for chat feature, and for other features, maybe very few people use them. So let's say your user base is growing very fast. Now you must scale this video recommendation feed, which means you must deploy more machines to do video recommendation feed, because all these features are compiled and deployed together because they are in the same binary file, right? So when you use more machines just because you want to do video recommendation feed, actually you also use all those machines for e-commerce feature, chat feature, and people following feature, even though you don't need these features to be on those new machines, right? That's a waste of a sauce, right? So in this case, you just want to scale the video recommendation feed, not other features, right? But in monolithic architecture, you cannot do that. So this is the scalability issue. So these are the three main issues we could have for monolithic architecture. Okay, cool. Now let's see what happened if we use a different architecture, which is, I believe you hear it a lot, which is microservice architecture. So in this architecture, you do not have a single code base. So we can just remove the box here. So each feature has their own code base and it can be deployed independently. So for example, team A may be in charge of video recommendation feed feature. So they choose to use Golang to do this kind of work, right? Development. And then they can just use their own machines to deploy this video recommendation feed feature or codebase. And another team, maybe they are doing e-commerce work, so they can choose use Java to do the development, and then they have their own machines to deploy this e-commerce feature, and similar to the other two features, right? So, and the app, when they send a request, so for example, when you want to get the new recommended videos, you just talk to this video recommendation feed, right? And if you want to sell and buy products, you just talk to this e-commerce feature. And then you can just talk to chat, you can just talk to people following feature, right? So you just talk to the components or the service which is in charge of the feature you are using right now. Okay, so now let's compare the pros and cons, right? I think it's in the reverse, you can imagine, right? So the pros here from the monolithic architecture will become the cons, right? So you can use multiple language. So e-commerce can use Java, video recommendation feed can use Golang, right? And there is no single point of failure. For example, let's say chat feature has some bug, then yeah, the machines for chat feature will go down. However, it doesn't affect any other feature, especially the video recommendation feed. So when user use it didn't feel any blockers, right? They can still use other features. However, in a monolithic architecture, if there's bug in chat feature, then the whole system will go down. And just because chat feature has bug, the user cannot use the whole app at all, right? So this is the benefit of microservice architecture, where you have no single point of failure. The third one is the scalability, where you can just scale the video recommendation feed. So for example, more and more people are using recommendation feed, then you just buy more machines and deploy more machines for this video recommendation feed feature or service, right? All other services or all other features, they just keep using the same machine. You don't need to buy more machines for them, right? So this solves the scalability problem. Okay, so seems microservice architecture is way much better than monolithic architecture. So why should we still use monolithic architecture, or what's the cons for the microservice architecture, right? The first thing is it's very hard or more complex to implement, right? I think I don't need to explain more about it, because you definitely have to use different languages, or you have to deploy different machines for different features, and you have different management, right? And more importantly, because they are on different machines or different clusters, how they communicate with each other. So for example, the chat feature may need to use some product information from the e-commerce feature. So how he can talk to it, right? So this is more complex if than the monolithic architecture because they are on the same machine, right? They are deployed together. So the second one is it's hard to debug. So still the same example. So let's say chat feature needs to use the e-commerce features service, and the e-commerce feature may need to use another service, which is user profile feature or service, right? So in this case, chat feature use e-commerce feature use the user profile feature. So they need to talk with each other. You need to get data from the other services, right? Let's say in chat feature service, you find a bug or you find some exceptions or some errors you want to debug. That means you also need to get logs from the e-commerce feature or from user profile feature, because a bug may not be caused just because of the chat feature. It could be caused all along the way from all the dependent services you are using, right? So you must get all the logs, and you must link all the logs together to analyze a single bug, right? So it's very hard to debug. And the last one is strong consistency. Okay, so what does this mean? So let's say in the app you are doing some operations, and you need to write, the app needs to write data, the same data, to both user profile feature and the e-commerce feature. Okay, maybe another example is better, which is you must write the data to both user profile feature and the people following feature. Okay, let's mark them. Okay, so you must write data to these two features. Okay, now strong consistency means you must either write the data to both of them, or the data is not written to any of them because of failures, right? So if they are on the same machine, they can use the same database, right? Which means you could use a transaction to do that. So the data could be written to both of them, or it could just be not write to any of them, right? However, in this case, in the microservice architecture, they are on different machines. So if you do not take special technique, which we will introduce in later sessions, in this fundamental sessions, so in this course, so it will happen that, okay, the app writes data to the user profile feature, but due to some errors, when it writes data to people following feature, it fails. In this case, you can see user profile feature gets the latest data, right? However, the people following feature didn't get the latest data. You can see these two services are now in inconsistent state, which could introduce some problems in future, right? So this is the third con of the microservice architecture, which is strong consistency. Okay, cool. Now let's have a retrospect. So we introduced the high-level components of the system, which consists of app, server, and database. We also introduced two different architectures of the system. One is monolithic architecture and one is microservice architecture. So yeah, thank you for watching this video, and see you in next session.